Good afternoon, everyone. Today we're going to focus on a unique type of question that you're probably going to see on exam one called birthday problems. Birthday problems are known for being one of the more hard questions on the exam, not so much because they're based on new concepts, but rather because they're combining multiple different topics that we learned prior to this into one lengthy, detailed problem. The problems, like I said, tend to be lengthy and that often trips students up as they miss small details. In terms of the actual exam, it tends to only be one question, and it also is multiple choice. And that's nice because Banco often, his answer choices aren't tricky. So if you get an answer choice, it tends to be the right answer. I would recommend to leave these birthday problems for the end of your study plan, just because it is one of the more harder questions, and it's also weighted the same as all the other questions on the exam, 5 points. So I would recommend mastering all the prior concepts. You can get those points as they're much easier questions than these. And also because this compiles all of the past topics from the exam, making sure that you know how to do all of them is essential in getting these questions right. So what type of topics are going to be touched on in the birthday problems? You need to understand how to set up a successful timeline. So knowing when the payments begin, when they end, ordinary annuity due, stuff like that, as well as how to construct and reconstruct effective interest rates. So most cases you're going to have to convert a nominal interest rate into effective ones. Sometimes you're going to have to deconstruct them, and this can be tricky, however, it's necessary for accurate calculations. And also, you're going to need to master your financial calculator. So that's knowing tips like the swap feature, cash flow register, knowing how to go between begin mode and end mode. Stuff like that is going to be essential in getting these questions right. And in my experience, I noticed that there's three main types of birthday problems. The first one is going to be funding a child's tuition fund. The second one is retirement savings, and the third one is insurance policies. Normally, you're either finding a payment or a future value or a present value, and it's pretty easy to tell in the question, and you'll see that in the example that we're going to do. And for my tips for success is to practice, practice, and do more practice. I recommend doing all the problems which StudyEdge gives you. Initially, it is really discouraging because you're going to miss the small details. However, the more you do it, the more you're going to pick up on the small nuances that are in the questions, and you're just going to go on autopilot on the exam, and you're going to know exactly what to do. And in my experience, that's how it was, and I was able to successfully do them. I also recommend when you're doing the exam, you use different colored pens when drawing out the timelines. So get a red pen, get a blue pen, get a black pen. Personally, I like to use red when I'm doing cash out and green when I'm doing cash in. And it just helps keep it organized because you'll see with a lot of these birthday problems, the timelines can get extremely complicated and intricate. And if you're using one color, it might trick you up. And also, prior to starting the question, I would ask yourself what it's asking. It's typically at the end of the problem. However, is it going to be a payment? Is it going to be a future value? Stuff like that. And just pay close attention to interest rates and time periods. Is it telling you of payments every 6 months? Is it every year? Quarterly? Stuff like that often tricks students up. So the first example we're going to go into is a tuition problem. So assume that you're planning your child's education. You would like to make a deposit every 26 weeks, a half year. So that's semi-annual deposits, years 0 through 21. With your first deposit made today, a total of 43 deposits, so that your child can make withdrawals in each of the years 18 through 21 for tuition. Tuition is currently, so in year one, is $3,000, but is expected to grow at 3% for each of the next 10 years. Then at 6% for years 11 through 25. If you can earn a stated or nominal annual rate of 8.476%, but interest is compounded weekly, 52 weeks a year, how much must you deposit every 26 weeks? So let's break down this question and make it a little more digestible. So the first thing I see is we're going to make deposits every 6 months, so half a year, and we're starting today. That's important. Also, we're going to make withdrawals in years 18, 20, and 20, 18, 19, 20, and 21. and tuition's currently $3,000, but it's going to grow at 3%. So we're going to have to do some growth factor work and get it up to that future value. And also here we're being shown that it's a stated nominal rate, so we're probably going to have to convert that to an effective rate. So let's start with drawing out the timeline. So in year 0, we're going to make our first deposit. Year 0 is also today. So it's some X value. We're not sure what that is. And as you see at the end of the problem, this is what we're going to have to figure out. So we're going to be making those every 6 months. All right. And then also in years 18 through 21, let's put that on our timeline. We're going to be making withdrawals. And right now, we don't know exactly what those withdrawals are, so I'm just going to put a minus X for that. And how long are we going to be making payments, are green? And it says right here we're going to be making a total of 43 deposits. So we're going to do it from today all the way through year 21. So while our child is withdrawing funds from the account, we're still going to be making contributions to that. That's important to know. All right, so just thinking about this and removing all the complications of the interest rates and all that, think about it this way. Our student is going to have to take out funds in years 18, 19, 20, and 21. So doesn't it make sense that we're going to have to find the value of the tuition payment or of the tuition cost and figure out how many monthly payments we need to make to equal that? So the first thing I want to do is I want to figure out how much this tuition costs. So in the corner, I'm going to create a little chart to just keep it organized. So over here, I'm going to do years. And over here, I'm going to do money. So in year 0, we know that tuition costs $3,000, but it's going to grow at 3% for each of the next 10 years and 6% for years 11 through 25. We need to find it at 18, 19, 20, and 21. So at years 18, it's going to cost $3,000. However, it's going to grow at a rate of 3% for 10 years. And then it's also going to grow at a rate of 6% for 8 years. And technically, what you could do is you could do 3,000 times 1.03 times 1.03 and do that all the way up to 10 and then 18 with the 6%. However, that's going to take way too long. So this is kind of just a shortcut to get that done a lot faster. So let's figure out what that answer is. So we're going to do 1.03, raise that to the 10, times 3,000. All right, I'm going to save this value. 1.06, raised to the 8, times that previous value. So tuition is going to cost $6,425 in year 18. So let's write that out. And we're going to write all the decimal points out just so we can get a fully accurate answer. All right, so in year 19, we're still only going to be increasing it by 6% because that's in years 11 through 25 and we're in year 19. So we're going to take this rate, multiply it by 1.06. That's going to equal $6,811 and change. All right, to find year 20, we're going to do the same thing, multiply by 1.06. That's going to get us 7,220.24865,686. And lastly, for year 21, we're going to do the same exact thing. A little repetitive, but it's okay. And it's going to be 7,653.46 357627. All right, so we know how much these payments are right here, or these withdrawals, I'm sorry. And now we're going to have to figure out what is the value of them all together. And to do that, we're going to need an interest rate. To me, this graph or this table that we set up kind of looks like a cash flow register. So my plan is to enter this all in to find a value, a present value. And to do that, we're going to need an interest rate to type in. So we see here that we can return an 8.476 rate. So a common trick that Bank is going to do is students are going to enter that in as the interest rate in the cash flow register. However, that's wrong because this is a nominal annual rate, and we're told here that there's weekly pounding of 52 weeks. So this rate isn't including the 52 weeks of compounding. So if you recall, our effective rate equation is 1 plus INOM over how many compounding we're going to do. So number of compounding. And then this is going to be this times over here, whatever number that is, minus 1. So let's go ahead and do it for this example. So how many times are we going to be withdrawing? We're doing it on an annual basis. So we're going to find an effective annual rate, which in my mind just equals 1. So if it was semi-annual, it would be 1/2. And we're going to set that equal to 1 plus our INOM in percentage form. And so that's going to be 88476, 0.08476. And we're told that there is weekly compounding. There's 52 weeks in a year. So we're going to set that over how many times we're compounding, 52. And this 52 times the annual of 1 is going to give us 52. And don't forget, we need to subtract 1. So let's figure out this. So let's do times 100. And we get this effective rate to be 8.8380700028. And this is the rate that we're going to use for our cash flow register here. All right, so as you can recall, we're just going to enter in all these values that we had. So our first value is going to be the 6425.99560062. We're going to hit right here, 0. 6811.553366. Enter. 7220.24865686. Enter. 7653.46357627. Enter. And now we're going to enter in our interest rate, and that's going to be in the actual percentage form. So that's the one that we just found, the 8.838070028. We're going to do IYR, and then we're going to hit downshift and PV. So that $24,000 isn't necessarily what we're needing, because this is saying the value of all these cash flows in year 18. And in this case, we're going to need to find it for year 21 because we want to set these total withdrawals equal to these annuity payments, these deposits that we're making. So in order to find that, a trick in the calculator is we're going to do downshift swap. And so this value, the 31,865, is the value of all of these withdrawals of tuition in year 21, and that's what we need. So I'm going to write that. Let me erase this. I'm going to write that down here at the bottom. So at year 21, it's going to equal 31,865.4389996. Alrighty, so that was the bulk of the work for this question. And now we can figure out how much these green deposits need to be. So let's go ahead. I'm going to make this just a tad bit smaller, just so we have some more room to work. Let's draw out our table. We're going to do N, I, PV, PMT, and future value. And right now, I'm going to choose to do end mode. And for end mode, remember, it needs to be one period prior to the first payment. In this case, our payment is in year 0. So I'm going to go back one period, which isn't 1 year, it's 1/2, because remember, we're doing our payments semi-annually. And so, and I'm choosing to do this because I want the present value to be 0, and it's just a lot cleaner when you set it up this way. And so let me write end mode so I don't forget. And so what's our present value at year negative 0.5? 0, because there's nothing there. And for our n, how many payments are we, or how many deposits, how many payments are we going to be making? Well, fortunately in this question, we were told that it was 43 deposits, so I'm going to write that in there. Our I, we still don't know, we'll figure that out. Our payments is what we're solving for. And our future value at year 21 is going to be this value we found previously. So now let's find our I. Again, a common mistake students will make is they're going to go ahead and use the 8.476 rate and for the I. And that's wrong, because this only takes into account a nominal annual rate compounded weekly. And we're going to need a semi-annual effective rate, which is compounded weekly. So let's do that. So our effective semi-annual, so that's going to be 1/2, equals 1 plus our INOM, which was 0.08476, over how many times we're compounding? 52. All right, 52 times 1/2, that's 26, minus 1. All right, let's put that into our calculator. All right, and we get 4.3254885874. And that makes sense because since we're doing it semi-annually, it's going to be around half. So just a little check. So let's write that out. 4.3254885874%. And so this is going to be what we enter in for I. So now we can do the final step of solving for our payments. We're in end mode, remember. So if you're in begin mode, make sure you switch out that. We're going to do 43 for n. Our I is going to be the effective semi-annual rate that we just found of 4.3254855874. Our present value is 0. And our future value at year 21 is going to be 31,865.4389996. And our payment is going to be $266.23. And that is going to be answer choice A. And that is the end of this problem. Thank you all for watching.